Welcome to the Fizz Buzz implementation. I have IntelliJ started up here and I've created two classes. One is the main implementing class that we're calling Fizz Buzz, and then the other one is the test class called Fizz Buzz Test. Now, TDD is, of course, a test first methodology. So let's do our test first on the basis of the breakdown of requirements that we did earlier. This is all we're doing for now. Let's do the first step. Write a program that accepts a sequential number and returns it. Man, that's easy. Surely that's easy, but we're going to do it in a TDD way. So let's name the first test that will do that and call it test. See, make sense, right? Okay. So if you're familiar with JUnit, you'll be familiar with assert equals. Use it all over the place. So if you type in, or if it's your turn and you're number one, then we expect you to say 1. As you can see, I have put in a dependency on the implementing class here. Because this particular tutorial isn't about using Spring Framework or anything like that for dependency injection, or using dependency inversion as a design pattern or anything like that, we're just going to put a straight dependency in there by using a new keyword, and that's fine for this, for demonstration purposes. We don't have a method on FizzBuzz yet. FizzBuzz is a blank class, but we're going to need a method which will return what you're supposed to return. In this case, in this case, the number 1. So we're going to have to name that. Let's call it say number, say sequence or something. Say number. Okay, say number for number 1. That's not implemented yet. So let's use IntelliJ to help us put a method signature in there. There you go. Now, it's very important to understand the concept of red-green refactor when you're doing TDD, and particularly when you're demonstrating TDD. The first thing that we're going to do is run the test without having done a full implementation. And we're going to expect the test to fail. It'll compile, the test is there, but we're going to expect it to fail. And that's our red phase. Then we're going to put the implementation in properly, and that'll be the green phase. And then we're going to do the next phase, which is refactor. That means applying good programming practice to the implementation and the test as well, making sure that the reusable parts are made reusable, make sure the solid principles are applied if necessary, and that kind of thing. The whole refactor stage is if necessary. So we don't have to go red, green, refactor, we can go red, green, red, green. Let's see how that works. Okay. Let's put a few more tests in though. If we're up to number 2, we would expect the person to say 2. If they're up to number 3, nope, number 4, because number 3 is divisible by 3, and we're going to save that for a later requirement. Okay, there's 3 tests there, which should work. Or should they? The tests are valid, but we're in the red phase. So there are test failures. Yeah, 2 right there. We've done red. Now let's turn that to green. Simple string, value of the number that gets passed in there. Let's see if that's turned to green now that we've done the implementation of this one simple requirement. Yep, test run 1, failure 0, error 0, skip 0. That's green. So, do we want to refactor? There's not enough code there to refactor. I think it's fine, and I think the test's fine. No need to refactor there, so we're going straight back into the red phase for the next requirement. And the next requirement, if you remember, is fizz. test fizz. Fizz is all to do with the number being divisible by 3. So I guess we're going to put 3, 6, and 9 into our say number. 6 and 9. Remember, we're still in the red phase. So run the test and we're expecting a failure. Such is the nature of the red-green refactor method. And it fails because we haven't put the implementation in. So let's put the implementation in. Here you need to have memorized the modulus operator. It's a rare operator. It's not something that you usually use. It's a operator that tells you what the remainder is when you divide a number by another number. So here we're going to say if I modulus 3 equals 0. What that means is if you take number I, whatever it might be, and divide it by 3, the remainder should be 0. In other words, is this number perfectly divisible by 3? Modulus operator. Good one to know when you're doing Fizz Buzz specifically. And what we do, return Fizz Buzz. Excuse me, return Fizz. Okay, let's double check the requirement there. Fizz with a capital F. Okay, that's fine. I can deal with that. That just goes to show it's always good to go back to your requirement and double check the requirement. So let's test this. We should be in the green phase. Let's see if I've made a mistake or are we in green? We're in green. Test run 2, failure 0. That looks good to me. Next phase, if you remember the requirement, for multiples of 5, it should print buzz with a capital, right? We're back in the red phase, the red zone. And this is multiples of 5. 5 is a multiple of 5, okay? 10 is a multiple of 5. 15 is a multiple of both 3 and 5, which is the next requirement. So let's skip that for now and just say 20. 20 is also a multiple of 5. That number of tests will do. You don't have to test every single possibility. That would just be impossible. You would end up with combinatorial explosion. And that's not what we want. So we need a sensible sample there for test buzz. Check it out. Let's see what is supposed to happen here. And what's supposed to happen is red. Still in the red phase. So let's turn that to green. And we say else if. Okay, else if it's divisible by 5, print buzz. There you go. Let's see if we're in the green phase. Okay, we're in the green phase. Done. Next one, Fizz Buzz if it's divisible by 3 and 5, which is the same thing as something being divisible by 15. More on that in a second. Fizz Buzz. 15 is divisible by 3 and 5. So is 45. So is 30. Okay. Test Fizz Buzz. Right now we're in the red phase. So we'll see what happens here. I guess it will be red. There it is. It's red. And here we are. Here we have to be careful with the implementation. remember, we're looking at something that is both divisible by 3 and divisible by 5. So we can't do what we did with the last one and just put it on the bottom here. We're going to have to put it on the top, because that one will be the condition that's first assessed. Let's do it. If a number is divisible by 15, then return Fizz Buzz. Else if, yeah, and then you go into the other ones there. If we hadn't put this at the top, if we put it at the bottom, of course, because 15 means it's divisible by 3 and 5, it would have just returned the first one that it came to, whether it was 3 or 5, in this case 3, and that result would have been wrong. Now let's see if that result is right. Let's see if we're into the green phase. Yep, we're into the green phase. 4 tests run, no failures. That's pretty good. And now we've almost done Fizz Buzz now. We've almost done the whole thing. We've done all of this, but what we haven't done is the output yet. From 1 to 100 and prints them. So all we need to do is, obviously we write our test, and then we wrap this whole thing in a loop, and we test that, and then we'll output it in main so that we can run this program on the command line. And for that, I'll catch you in a moment.